So Redux is a relatively new library. It's not brand new, but it's only like 7 or 8 months old now. Um, it replaces, in many ways, the Flux architecture that was originally proposed by Facebook. And it's actually a simplification of the original Flux architecture. And in many ways, it makes your life much easier as a developer. So many of our original projects, we used Flux. That was sort of the recommended path from Facebook and from the developer team who put together React. So we used that, and it worked really well for us in most of our projects. However, over time, I think that as we began to use Flux on larger and larger projects, we felt like there was a lot of redundant code. Then Dan Abramoff, I think it was at the React conference, at this conference right here, at React Europe in 2015, announced Redux and presented that in his talk back in June. And since then, we kind of put it off for a little while because we figured that we would just move to Relay and GraphQL. But as it turns out, Redux is a really great platform, really great framework for handling your data. So we're going to talk just a bit about that today and when we would use it and why. There are some really great documents up on the web. Just do a search for Redux. There's a great video for React from React Europe, and I would highly recommend, if you're interested in Redux, going to egghead.io. Just do a Google search for egghead.io and Redux. Dan Abramoff himself has done these 30 lessons, and it explains the kind of thought process put in to develop Redux over time. So this is a really great resource. I'm just going to show a quick overview. So let's talk a little bit about that. So at the heart of Redux is a single store, and your single store is just going to be a JavaScript object. And that's it. There's nothing special about it other than throughout the life cycle of your application, this store is going to be immutable. Okay, so let's talk about what I mean by that. In your application, there are going to be events and probably API calls and a number of different things that are going to result in your store needing to change data. And so then you ask, well, if I have an immutable data store, how do I get data from an API? Or how do I respond to a user typing into a text box? And that's where reducers come in. So the only way I can change my store is through a reducer. And a reducer is a pure function. It simply looks something like this, where the first parameter to the function is state, and the second is action. And then that function is responsible for returning new state. All right, so right here you can see I'm just returning the state that I was given. That doesn't really help me much. But if for some reason that action, maybe I used action.type, it's entirely up to you how you put your application together. Most of the implementations I've seen, everybody puts a type on their actions. And I'll show you how you create actions, but for now, just know that an action is also a plain old JavaScript object that looks something like this. So I might have a type, and it is the type is change user. So then inside of this reducer, maybe I care about that, and I want to respond to change user. Well, when I do that, I have to return a different state. So state up here may have had a user object inside of it, something like this, where their name was Bill. And this action might have a new name for the user, and the name of the user now has to be John. Okay. So now I have to change this user's name, but I can't change this state that was given to me because the store has to be immutable. So instead I have to make a copy and return a new state. So this old state that was given to me will remain in existence as long as somebody refers to it. And as long as somebody is referring to it, it won't get garbage collected. And I'm not going to change it out from underneath them. We've actually had this happen to us in different Flux applications where weird things have occurred because somebody changed a piece of data that somebody else was using, and then it was updated in the UI, and we couldn't figure out what was going on. So in this case, we don't want to return our original store. We're going to return a new one. So now I can take this state, and through the magic of ES6 syntax, I can splat out the original state, which is going to be this user object right here. Let's see here. Yeah, this actually is more complicated. Let me just do this. Let's pretend like we don't have to do deep stores, because that becomes a whole other issue. So this will take this original state, and now I want to add in this new name, and I'm going to say the name is from the action.name. Okay. So this will deconstruct whatever is in state, all of its keys, name Bill, right here. And then when I put name here, it's going to overwrite the name from this state with this name right here. And now I'm returning a new state object. Now that's handy if I had other things in here, like maybe their email, something like that. So I want to keep all these other properties around. Now that could get to be a little bit painful if I'm always making copies by hand and dealing with the immutability of the data store on my own. We actually use Immutable.js, which is this library right here. It's from Facebook. It makes your life a little bit more challenging in some ways, but much easier in a lot of other ways. This implements a really efficient mechanism called trees for dealing with immutable data types. So I would look into that if you're going to use Redux, and in fact we use it in most of our projects. So like I said, the alternative is to do something like this. There are a few other libraries. Like there's one Seamless, what is it? Seamless Immutable or something like that. If you Google around for immutable, oh, and Morty I think is another one. Morty. Yeah, anyway, if you Google around, you can find a bunch of different libraries that handle immutable data types in JavaScript. Okay, so this function right here is a pure function, meaning it doesn't call an API. It doesn't change any kind of global state or even state inside of the store, other than to say if you are responding to a specific action type, it's going to return a brand new state. So this thing that's being returned here is different than this thing right here. And that's important because Redux depends on things being immutable, that you aren't changing the state out from underneath your components. Okay, so now you might say, well, I've got these actions, where do they come from? So this is a reducer. So this action right here is probably generated by an action creator, which is also a pure function that can take things like name, for example. And now this action creator is going to just return an object like that. Action creators, again, have no side effects, meaning they don't change global state, they don't make API calls. I think I've seen people make this mistake. I've seen people actually make API calls inside of their action creators. Don't do that. At least if you want to adhere to the architecture recommended by Dan Abramoff and kind of like the generally accepted mechanism for building Redux applications, your action creators are pure functions that just return JavaScript objects. In this case, that object that is going to be returned has a type, and it has some kind of a payload in here. In this case, we're going to change the name to John. Some people have very specific rules about how you build these actions. They say, oh, well, you'll have a type and a payload, and anything else that you are doing inside of this action, you need to put in the payload, so you would put the name there. And if you did that, then inside of here, you would have to do action.payload.name. It's up to the developer whether or not they want to adhere to a really strict set of rules on how you construct your actions, what those objects are going to look like. We don't. We don't put everything in the payload, but we have other kinds of actions that do specific things. So we might have an action that will result in an API call somewhere else, not in the action creator. And we have other actions that result in calls to specific APIs, do other things. And we do that through middleware, but we won't get into middleware today. All right, so now I have my reducer that is going to deal with my state. I have an action that can do things to the state. So how does all of this come together? And to show you that, I'm just going to walk you through some of the code that we have inside of our starter application here, and then you can actually go run some of it. So if you look inside of, let's see, configure store. Oh, there it is. In the store folder, there's this configure store. Now, configure store is done as soon as the application starts up. So in this application, app.jsx is where everything starts. It's kind of your main file. It's where Webpack is going to look to begin building your JavaScript application. So you can see I'm importing configure store, and so now I can generate this global constant called store from configure store that I'm going to pass some default data to. And this default data is passed to us from the server. So this is how you can connect default settings coming from a server and have that data end up inside of your store. And if you notice, I give it this key of settings. That's because there's a settings reducer that is going to pick up those settings and deal with adding that to the store. All right, so inside of configure store now, you can see there's a whole bunch of stuff going on. Most of this is tooling around our development process. You can see where you add a little bit of middleware right here. Your middleware, again, I don't want to get into it too much, but it can intercept your actions before they hit your reducers, and they can do stuff with that. And that helps keep your API calls out of the way. So your application can think of creating actions rather than making API calls. Okay. This stuff is just adding instrumentation, and then at the end of the day, here's the store that actually gets returned. So the store we compose from our enhancers here. Again, that's our middleware. This compose returns a function that you call with create store that you bring in from Redux. That returns a function, and that function you give it a root reducer, and I'll show you what the root reducer looks like, and you give it an initial state. And that initial state is what we passed right here. And in this case, we're passing this immutable object, immutable JS object. It doesn't have to be immutable JS, it can be just a plain old JavaScript object, whatever you choose. All right, so that line right here is actually the most important one in this file. That's the one that actually creates the store and adds any middleware and any initial state. All right, any questions so far? All right.
Question. So kind of one, I guess, big difference I'm seeing between Redux and Flux is a single store versus multiple stores.
Correct. There is just one store. But all of your data can live off of keys off of that store. And so you'll see that here in just a second. So in this case, see, I showed how our store was just one user like this, but in fact, it's more likely that your store is going to look something like this, where you have users, and then those users might have their ID, and here's the user data, and I might have a settings like this, and so on and so forth. Now let's talk a little bit about how that happens. So again, here in the configure store, you can see we bring in this root reducer. At its heart, you have one reducer in all of your Redux architecture. So the question is, well, how do I keep my store from becoming just a giant messy ball of data? And the answer is you write a lot of different reducers. And so the job of the root reducer, which is, where is it? Right here. Which is this guy right here, is to combine all of those reducers. So that when I give the root reducer to the store, right here, So you can see there it is right there. It is a combination of a whole bunch of other reducers. All of the reducers implement the exact same method signature. So if I go look at this reducer right here, you can see here's the method right here. Again, this is just an arrow function, just a nice handy shortcut notation. A little bit of other ES6 niceness here. We're setting an initial value. Talk about that more in just a second. But it's a function that takes two parameters, state and action. And then based on the action, I can do something to the state. Here's the settings reducer. Notice that it never changes. So it doesn't care what actions are sent out. It always just returns whatever state it was given. And that's because the settings came from the server and we don't want to mutate those values. We don't want to change them ever in response to any kind of action. All of these reducers are combined in this reducer. So you can see here's routing, settings, application, and messages. So when it combines these, I end up with an object that looks like this. So routing is something, settings is, each one of these becomes a key in my top level store. So when these reducers are executed, this state right here doesn't actually refer to this whole state out here. It only refers to this state right here. So for example, in the messages reducer, the state object that I receive right here is going to be this object right here. Because that's how this combined reducers puts all of these different methods, or all of these different reducers together. Does that make sense? Okay, I didn't hear any no's, so I'm going to assume that that makes sense. The nice thing here is that each reducer only has to care about its own particular piece of the state, and it can't change any other pieces of the state. When this messages reducer right here, for example, receives a message of add message, you might use this if you click a button and you don't want the user to be able to submit because they forgot to put in their name or something. You could send out an action with add message as the type. This reducer would then pick that up, and then you can see right here the state.push action.payload.message. Now that might look a little bit confusing because I said you can't mutate the state, and it looks like we're mutating state here. That's the nice thing about using Immutable.js, is that you can see our initial state is just an empty array, but that array is wrapped by an Immutable.js object. So the first time this is ever called, it's going to look like an empty array, sort of, but not really. That state is going to be one of these Immutable.js objects. So when I call state.push, it doesn't actually push anything onto the existing state. Instead, this call to state.push handles returning a new object, so that I don't have to make a copy of everything in that array and then return that, which is pain to do for the developer, and it's also inefficient. Like, it's going to take a lot of horsepower over time for you to make copies of everything. So Immutable.js has an implementation underneath the hood that prevents you from actually making copies of everything, but it looks like it makes copies of everything. So when I call state.push, this actually returns new state, which is nice. This makes my life much easier, so I don't have to deal with a lot of implementation details of how to copy state. So each one of these reducers combines, like I said, to make an object that looks like this. I guess messages is actually an array. So that's nice. It means each reducer only has to worry about the particular piece of state that it cares about. All right, so all of this then culminates at the components. We have to do something with this state. That's why we have all of this state. So if I go to my components directory, there should be messages JSX right here. All right. this is, remember, we have one global store. That store has a couple of methods on it. Let's see, going back to app.jsx, remember we've got this guy right here. So calling configure store, calls all those different methods inside of Redux and gets everything set up for us. And then we return this store object, this guy right here. Now the problem that we have is how on earth do we get this object into our different components that care about different pieces of state without having to pass them through the entire component tree. Now that's entirely acceptable. You can see right here, this is a root level component and I pass state as a prop on that root level component. I could do that through my entire component tree, but that's a pain because it means that even for components that actually don't care about state, if some of their children down the line, maybe not their immediate children, but their children's children's children in that hierarchy, if they care about state, I have to pass it all the way through. And that can be really, really painful and results just in a lot of extra code and components that have to know things about state that they don't care about. So the nice thing about Redux is that they have given us this connect method. So that's this guy right here. And you can see I just import connect from Redux connect. So connect, in this case, we're using it as a ES7 decorator. And by the way, this isn't the final syntax. There is still a Babel 6, there's a Babel 6 plugin that will handle transpiling this into ES5 syntax. And I suspect that ES7 will include decorators, but until the final spec is formalized, you have to use a plugin with Babel 6 to get this to transpile back. Anyway, you can also just call this as a method. So if I want to take this messages class, I can pass it into this connect, and we can do it in a non-decorator way. But the decorator mechanism is actually really nice because I just put this connect method above my class, and what that means is it's going to decorate this class with additional functionality. So what additional functionality do we get here? Well, you can see the first thing I'm passing to connect is a function. I like to call it select. You can call it anything you want. You could even put the function in line. This method that you pass as the first parameter receives as its parameter state. That is the global state. Now, where does that come from? Well, it comes from the store, but remember, we've got this store sitting back here that we made. If I call store.getState, this method right here is what will actually give me this data right here. So the store only has a few methods implemented. One of them is getState. The other one, by the way, is another one anyway, is dispatch. And I'll show you how to use that here in just a second. So this getState is going to provide us with the entire store. So in my messages component, I have this state, and now I have the opportunity to get the entire store. Now it might be really tempting to just do this. You say, well, give me all the data. The problem with doing that is now my component is tightly coupled to my global application state. And I don't want that. Instead, I want this component right here to not really know about state. I just want to pass it what it really needs. And in this case, the only thing it really needs is an array of messages, because its job is to render out messages. So by returning messages from the state as an object, this connect method will make this messages data available at this.props.messages. So now you can see that right here. And if I had returned something else, like users, and I wanted state.users for some reason, then I could access users at this.props.users. This also makes it really nice to test these components, because now instead of having to set up a whole bunch of state in order for the component to run, because the component reads directly from state, instead I just test this component by giving it the data that it actually needs. And actually in this case it looks like we went ahead and marked the store instead of the component, but typically you wouldn't have to do that. I'm not sure why we did that. Typically you would want to just test messages by passing it an array of messages, and then you wouldn't have to worry about setting up the store. So that's kind of handy. Pull this code back out. All right. The second parameter here is where you can pass in actions. And you can see in this case we're just passing in null because we don't care about any of the actions. This component is only going to display messages. Let's say, for example, I needed to be able to generate an action from here that would add a new message. So this component was also in charge of providing a way to add messages. Well, I can do that too. Now I could write a method like this. Oops. And then pass that in. Oops. Actions right here. And this guy would be responsible for returning something like add message, which would be some function like this. And this guy receives dispatch. So remember I said there's a store.dispatch. That's how the store receives actions, and then that's how they end up inside it. Those actions hit the reducers. This is how I can dispatch and send those actions into the store. So I could call something like dispatch, and I could provide it with a message. So if I had this method add message, I could dispatch here and say, my message is message, whatever, something like that. And I would also need to give this a type, so add message. And then a reducer could look for the type add message, and it would pick that up. That's really ugly, though, and this is a lot of extra code. And in fact, I think we already do have actions for adding a message. Here's the action creator. Remember, I showed action creators before. So this action creator is just a function. It receives message, and it returns a plain old JavaScript object. That object has a type, has data. So we've already done this, in which case we can not have to redo it here. I just wanted to make sure that everybody understood exactly what's going on underneath, that this dispatch method is being called. And so let's go ahead and let's pretend like we're going to use that. So let's import add message from, let's see, from actions. Like that. All right. So now I could call that function directly. I could call add message, and it takes a message, and we could dispatch that. And that would work just fine. And then inside of this code down here, maybe I have a text box or whatever. Let's just write it out. Okay, so this is how I would call it, and I might call that in response to a user typing in a text box or something like that. So this function that I returned right here, this add message, is available at this.props.addMessage. You can see that that is also just a function that takes message as a parameter, which then passes it to this add message that I pulled in from my actions, and then it dispatches it. This ends up being a lot of extra code, and we use this pattern over and over again, and you can see we type out add message a whole bunch of times, which is a pain. So instead what we're going to do is we're going to say, all right, well, I have my function right here. This connect method provides a really, really nice way of doing all of this for you. So if I pass in an action creator, where the action creator abides by all the rules, it just returns a plain old JavaScript object, then Redux, rather the connect method from Redux, will handle all of this wrapping up for me. So I can just delete all of this code. This is, again, ES6 syntax. It would actually look like that, but I can shorthand it and just do this. And that's really cool, because now add message that I imported from actions is still available at this.props.addMessage, and I just eliminated 5 or 6 lines of code. So that makes my life much easier. All right, so now we've kind of come full circle. Inside of my what's that?
If all you were going to do was make the call, like in your event handler, you might not even have a separate function. You might just do it, right?
Make the call inside of the event handler. Oh, you mean this function?
Instead of defining a function called addMessage, you might just say like onBlur equals this.
Yeah, exactly. So yeah, I just typed it out because I didn't want to type all of it in. But yeah, I had something like this. It's text, and oops, I could do this, and on blur, we can just add a method here. On blur, there we go. And this is a function that takes the event, and I could just call it directly right there. And then this might be e.target.value, I think is what it is, like that. So this would then pull the text that you typed in this text box. As soon as you click out of it, it would call this add message from the props. So yeah, you can reduce your boilerplate code down significantly, which again is really nice. All right, so this message right here, again, is going to now hit a reducer because remember, it's wrapped everything up in that dispatch, which is store.dispatch. Well, store.dispatch results in this reducer being called. Well, it actually results in all the reducers being called, but this is the only reducer that's going to care about it because you can see here's the add message. This one matches. It updates the state. Updating the state then results in this guy re-rendering. And why would it re-render? Well, because this select pulls from messages, and messages has changed. And so there's something else magical that happens here, which is the connect method wraps my messages component in another component. So that parent component that's more or less invisible to the developer is going to recognize that this changed, and it's going to pass those new props into here, which will cause this component to re-render. I guess that's something that you might want to watch out for as you write code. Using Redux is if you start to look at the component tree, you're going to see another component wrapping your component. Don't think that that's like a bug or something weird happening. In fact, it's just Redux adding one little extra bit of layer through this connect method. And that extra component is the guy who goes to the context actually to get the store handles providing the props into your component. Again, that's one of the niceties. A lot of extra boilerplate code that you don't have to worry about writing because the connect method does it for you. Okay, any questions? All right. I realize that's kind of a quick overview of Redux and how we use Redux. If you want to see the code, you can either pull down the daily training, or better yet, I would recommend pulling down the React client starter app. That's the one that stays the most up to date. I'll post all these links with the video, and do watch Dan Abramoff's presentations because I think that is a really great way to understand Redux. And that's it. Thanks.
Thanks.